Hi everyone, today we are going to talk about measuring angles and arcs of circles. So the first thing we're going to talk about are what are called central angles of a circle. So if you create angles that have a vertex at the center of the circle, those are called central angles. So for example, 1, 2, and 3 are all central angles of this circle. Now, one important thing to know is that the sum, meaning that we're going to add, of the central angles of a circle is always going to be 360 degrees. So we can create an equation for this circle. We could say that that angle 1 plus angle 2 plus angle 3 should always equal 360 degrees. Now, please don't get that confused with the triangle sum theorem. Remember, for a triangle, the sum of the angles is 180. For a circle, it's 360 degrees. Now, we can use this fact to help us find different angles within different circles. So let's look at this first example. Here, they would like us to find the measure of angle AOD. So they want us to find this angle. However, to find this angle, we're first going to need to find x. Now, if I look at this circle, I am given that this angle is 25x, and this tiny sliver is 3x, and this even smaller sliver is 2x. Now, if I look at this picture, I can see that if I cut my circle right here, I actually have all I need to make exactly half of a circle. So if a full circle will add up to 360 degrees, I know that half of a circle, the angle should add up to 180 degrees. So I can start solving this problem by setting up an equation. I know that 25x plus 3x plus 2x, all of those angles should add up to 180 degrees because it's exactly half of the circle. So from here, I'm going to combine like terms and then solve for x. So x equals 6. However, remember, we did not want to find x. We wanted to find angle AOD. And I can see that from our picture, angle AOD was 25x degrees. So now I'm going to substitute the value that we know, 25 times 6. So angle AOD is going to be 150 degrees. There you go. All right, go ahead and pause the video and give this problem a try. Same figure, but now you're finding angle AOE. Okay, let's look at the information that we have here. We know that we are trying to find, let me trace it out, AOE, this angle. Well, we also know that this angle and this angle put together, those are vertical angles, so they should be congruent. So we already solved for x in that last problem. We know that x equals 6. So I know that if I add up these two angles right here, that the sum of these two should equal this. So I know that angle AOE should equal 3x plus 2x. So angle AOE should equal 5x, and then I'm going to substitute the x value we know. So angle AOE becomes 60 degrees. So you can see that we're still using information that we learned previously, such as the properties of vertical angles. All right, so now we're going to take a step back from the central angles and we're going to look at the outside of a circle, which is called the arc. Now, the arc, the measure of the arc is always going to match the measure of that central angle. So there's 3 types of arcs. There's a minor arc, which is any arc that's less than 180. There's a major arc, which is any arc that's more than 180. And there's a semicircle, which is any arc that is exactly 180, or a half of a circle. So there is a specific way that you must name these types of arcs. So for a minor arc, I know that these two pictures look the same, but there's actually two different arcs. So the minor arc would be this one. And we can name any minor arc with the two letters where your arc starts and ends on. So we could say arc AB, and you put the little arc over it. Now for the major arc, same circle, but this time we're looking at this part of it, the part covering the rest of it. So you can see that this is bigger than 180. Now for an arc that is more than 180, we have to actually use 3 letters to name it. So let's add in another point. You have to have 3 points to name it. So we would call this A, M, B, and then you put a large arc sign over it. If you just said AB, I'm going to think you mean this one. So the only way that you can make sure that we know we're going around the larger side is by giving a letter somewhere in the middle. Now for the semicircle, same thing. We need to know 3 of the letters. If you just said arc AB, I don't know if you mean going over the top or the bottom. So here there's actually 2 arcs going on. There's arc ACB on top, but there's also arc ADB on the bottom. So you have to use 3 letters so I know which part of the semicircle you're talking about. All right, let's see if we can use what we know about the arc lengths to find these 3 values. But first, let's zoom in on this picture. For these types of problems, I like to go through and fill in any information that I have before I even look at what they're asking us to find. So if I look at what we have, we know this is 50 and this is 90. And we can say that this is 50 because these 2 angles are vertical angles and therefore they are congruent. Remember, this box means 90, so that means that this is also 90 right here. And if this is 50, this must be 40, so it adds up to 90. Well, then I have 2 options to find this remaining angle. I could say 50 plus 40 plus 90 plus 50 plus x equals 360, or I can use a little shortcut. I see that I have a semicircle right there. I'll do it in green. Well, I have a lot of semicircles, which should add up to 180. So I can say 50 plus x equals 180. So that last angle is 130. So now that I know all of the angles in my the central angles, it makes it a little easier to work with the arc lengths. All right, so let's start with the measure of arc BE. So as I mentioned before, the arc length measure, the measure of the arc will match the central angle. So I can see that arc BE goes with this angle of 50, so that's the measure of the arc. All right, so now let's look at CBE. I'm going to trace over that with a highlighter. So CBE is this entire arc right here. So I have to add up the 2 parts that I know. I know that it should be 90 plus 50, which will be 140 degrees. For this last one, let's look at arc ACE. That goes from here to here, all the way around to here. So there's 2 ways we can do this. We can either add up all of the parts. So we can say 50 plus 40. We can say 50 plus 40 plus 90 plus 50, and that will equal 230. So that's one way we can do it, or we can work our way backwards. We could start with the entire circle, and we could take away the part we don't want, which is 130. And we end up with the same exact answer, 230 degrees. So go ahead and pause this video really quick. It's the same figure. See if you can figure out what those 3 arc measures are. All right, let's check your work. Arc CD should be 40 degrees. Arc DCB, that's from here to here to here, should be 130 degrees, which is 90 plus 40. And then CAE is going to be this entire arc right here. So those three added up should be 220. There you go. Okay, the last thing I want to talk about is how to find what's called the arc length. So now we're no longer working with the measure, we're actually working with the length. So imagine you took a string, laid it on your circle, and then took that string and measured the length. That's going to be the arc length. So there's a simple formula for this. It's just theta divided by 360 times your circumference, which was 2 times pi times r. So remember, theta is the Greek letter we use for angles, and that's going to be the measure of your arc, and then r is your radius. So let's give this last problem a try really quick. When they ask us to find the length, I'm going to always start by writing my formula. And for this one, they gave us everything we need. We can see that that angle, the measure of our arc, is 120 degrees, so that's theta. And we can see that our radius is 15. So I'm just going to substitute those into our formula. And 2 times pi times 15 is 30 pi. And now all I need to do is simplify. So here I can divide by 10, and I can continue simplifying that fraction by dividing by 12. 12 divided by 12 is 1. 36 divided by 12 is 3. And this will give us 30 pi divided by 3, which is just 10 pi. All right, last problem. Go ahead and pause the video and give this one a try on your own. All right, let's check. It should be 45 over 360 times 2 times pi times r, so we should get 24 pi. We can simplify 45 over 360. It will become 1 over 8 times 24 pi, and 24 divided by 8 is 3. So we end up with an arc length of 3 pi. All right, that is all for today. Thank you for watching.